5.3 molecular shapes. It's also called VSEPR, valence shell electron pair repulsion. So for this, you will be given on a test this sheet here, this chart sheet. It's abbreviated, but here is the long version of it that we will use today. So what is VSEPR? VSEPR is valence shell electron pair repulsion theory. It really is helping us organize the atoms in a particular arrangement such that we could see the angle and the shape of that compound. And so we talk about these things called charge centers or electron domains. And the domains really are the items around the center atom. So here's the center atom on that compound, and here's the center atom on that compound. So carbon would have 1, 2, 3, 4 domains, kind of electron domains surrounding that carbon, and then nitrogen over here would have 1, 2, 3, and that lone pair there is also called a domain. So that one has 4 domains around it, and that one also has 4 domains around it. So you can see here it says the groups are the domains. So hydrogen could be a domain. That OH, which is a grouping, could be a domain, and we kind of count it just as one grouping around the center. And also the lone pair electrons can be groupings. And so after you draw these Lewis structures enough, you kind of get a feel for the shape of it or how you would draw it. And so you got to make sure you always take into account the lone pair electrons. That's why it's so important that you always write lone pair electrons if they're on the center or maybe even on the outside atoms, although the lone pairs on the outside atoms don't impact the angle or the shape for what we're going to do. And then you'll need to be able to count the number of bonds and match it up to this chart. So some things to note: hydrogen always bonds once. It will never have a double or a triple bond. The halogens are group 7A. They're fluorine through astatine. They're the ones clear over here on the periodic table. They're not the noble gases. They're right near it. They single bond. They're a 1- charge. They will single bond. Carbon will always have 4 bonds. It could be 4 singles. It could be doubles or triples, a combination of. Nitrogen tends to bond 3 times, although that's not always true. And oxygen tends to bond twice, although that's not always true. But they're things to aim for if you are completely lost. And so how to use this chart? So the great thing is that the very top thing of this chart means you have just 2 atoms, like maybe X and Y. So if you have X and Y, the furthest apart X and Y could ever be from each other is 180 degrees, like 180 degrees. But it's when you get more than 2 atoms, for example, if you had 3 atoms, atom there, an atom there, an atom there, an atom there, you have 3 things coming off the center. That's where you would get an angle and a shape. And these atoms that are attached to the center want to be as far apart from one another as possible. So if you have 3 charge centers or 3 things on the center and 0 lone pairs, notice that 3 plus 0 adds up to 3. What I'm going to tell you doesn't work for everything, but it works for this. So 360 degrees divided by 3 is 120 degrees apart, and it's called trigonal planar. So let's say you had 3 atoms on the center, 1 lone pair. You had 3 charge centers. I said that wrong. 1 lone pair and 2 atoms on the center. The 2 plus the 1 equals 3. I did that other one backwards. And again, 3 into 360 gives you 120 degrees. But this one's called bent. It's because of that lone pair electrons, because one of those atoms was not an atom. It was a lone pair. So let's say you have 4 things on the center and 0 of them are lone pairs. 4 of them are atoms. The angle, it really varies from 105 to 110. I like to just call it 110 to keep it simple. And it's called tetrahedral. A little tip here: 4 things, 4 atoms attached to the center. Remember, the prefix tetra means 4. So it's a tetrahedron. So again, if you have 4 things on the center, but one of them's a lone pair and 3 of them are atoms, it's still 110 degrees, but it's called trigonal pyramidal. It looks a little bit like a pyramid. And again, there's one more option: 4 things around the center. 2 of them are lone pairs, 2 of them are atoms. Again, the angle is about 110. It's probably actually a little less than that, but we're just going to call it 110, and that's called bent. So if we scroll through here, you'll see these different shapes. You'll see the linear, the trigonal planar, the bent. So that is lone pairs there. It looks truly evil. Tetrahedral, so a center, four things on the center. The trigonal pyramidal, so it looks a little bit like a pyramid if you could draw that. And then you have these lone pairs on the top. They're communicating to celestial beings. And the last one is bent. So you have an atom in the center, two atoms on the side, and a lone pair here and a lone pair there. And that one is called bent. So let's practice this. So, before we practice, so what you really need to do when you draw the Lewis structure and you're trying to figure out the angle and the shape, you need to determine how many things are on the center, how many of them are lone pairs, and how many of them are atoms. And you really just match it up to this chart that'll be given to you on a test. So let's do this. So the first thing you do is you draw the electron dot structure of each atom, and you may get so good at this you don't have to do that part. And then you'll draw the Lewis structure and make sure you identify what the central atom is and make sure you put lone pairs on there. And then you'll use the chart to determine the angle and the shape. So let's do this. CH4, let's make it a wee bit bigger. So the electron dot structure, I'm going to go over here. Carbon has 4 valence electrons. I'm going to arrange the hydrogens around it because it probably arranges like that. And each hydrogen has 1 valence electron. And again, they like to share, so they have them in pairs. And these ones share perfectly such that we have 4 single bonds attached to the hydrogens. So carbon with 4 hydrogens attached by single bonds. So then you ask yourself, how many atoms are around the central atom? Well, there's 4. 1, 2, 3, 4. How many lone pairs of electrons are on the central, just the center, not anywhere else? 0. Carbon has 0 lone pairs of electrons. So what is the molecular geometry of this compound, and what is the bond angle? So we need to scroll. So what we have is a 4 and a 0. So we go back to our chart and we find the one that has 4 atoms. So 4 atoms, boy, it's a mess. So we have 4 atoms and 0 lone pairs. That means it is tetrahedral and it's 110 degrees. So I'm going to scroll back to where I was. And so you would say that it is tetrahedral. And you would say it's 110 degrees between each of those. And this is in 3D space. This isn't like just on a sheet of paper. That's why it's not 90 degrees. When you draw it, it looks like 90 degrees, but it's not. Let's try water. So the dot structures, oxygen is the single atom. It's on the center. It has 1, 2, 3, 4, 5, 6. And then we have 2 hydrogens. They each have 1 valence electron. Those share and those share. So it looks like this. So we have 2 single bonds and 2 sets of lone pair electrons. How many atoms are around the central atom? 2. How many lone pairs are around the center? 2. So we go to that chart, zippity-doo-dah, and we find the one that says 2 and 2. And right here is 2 and 2. It adds up to 4 things on the center. It's 110 degrees and it's bent. So water is a very cool molecule. We couldn't exist without it. So it has a geometry of bent, and it's 110 degrees. So the way we would probably really draw it is there's the oxygen, and we would draw these hydrogens a little bit at an angle. So it's bent. The geometry is bent with respect to those actual atoms. Let's try NH3. So N will be in the middle, and then we'll have H, H, and H. And in general, nitrogen likes to have 3 bonds. So it has 1, 2, 3, 4, 5. Each hydrogen has 1 valence electron. They will share, they will share, they will share. Those ones at the top are not sharing. So it looks like this. So we have 1 set of lone pairs. How many atoms are on the central atom? There are 3. 1, Let's count with the cursor. Is that a cursor? The arrow. 1, 2, 3 atoms on the center. Then how many lone pairs are on the central atom? And there's just one pair. And so then we look on the chart for a 3 and a 1. So 3 atoms, 1 lone pair. And this will be, we find the 3 and the 1, 110 degrees and trigonal pyramidal. So again, it's 110 degrees and it's trigonal pyramidal. There's some clues in here. Tri means 3 atoms, so we have the 3 atoms, and it looks like a pyramid if you draw it properly. So multiple choice questions. How many sets of lone pair electrons does a molecule of water have? So we drew water before. These are great multiple choice questions on a test. So how many sets? There's 1 set, there's 2 sets. So it's that. So in H2S4, what element would be in the center of the Lewis structure? Probably the S. How many, question number 3, how many bonds in total are in a molecule of pH3? P, H, H, H. Remember, H is only single bond, and so there might be a lone pair electron on the P, there might be more than that, but there are only 3 true bonds where the electrons are shared. Number 4, select the compound with a triple bond. So a triple bond tends to be nitrogen. We saw in water that they were just single bonds. This is an ionic compound, so that one does not apply. HCN and HF. Let's do elimination. So HF, H can only single bond. That's what that one really looks like. So that means this one. So if H can only single bond to that C, and C always needs 4 bonds around it, that means that one's a triple bond. And nitrogen's not quite finished. It needs those lone pair electrons. So this one has a triple bond in it. We're going to move on to question 5. How many electrons are shared in a double bond? So a double bond, there's those ones, and there's those ones. So how many electrons? 1, 2, 3, 4. Question 6, select the compound having a bond angle of 120 degrees. Okay, we did water before, and water is 110 degrees. KBr is ionic, so that does not apply, not applicable. BBr3, we didn't go over B today, but B can only bond 3 times. I think this one might be the one that's 120 degrees. NH3, we did this one previously, looks like this, and it has those lone pair electrons, and this one is about 110 degrees if you match up the 3 and the 1. So this one is the one that's 120 degrees. And again, boron can only have 6 valence electrons, 6 shared electrons. I hope this was helpful for you. I think we completed the notes, and I'll see you again next time.